This is a worked solution to AQA Physics P1 June 2014 higher tier paper question 4. This question is about sound waves. A frequency of 440 Hz means that there are 440 waves produced every second. In part 2, it tells us the speed that the sound waves travel at and asks us to calculate the wavelength of the note. Earlier on we were given the frequency. So the equation we need to use is one that links speed, frequency and wavelength, and that is that the speed of a wave is equal to its frequency times the wavelength. We need to substitute in the correct numbers, so 340 is equal to the frequency, which is 440 times the wavelength, which gives us wavelength is equal to 340 divided by 440, and that is 0.773 meters. And because I've got three numbers after the zero, there are three significant figures there. So question 4b sets up the situation in which the sound from the keyboard can be played through a microphone and displayed visually on the cathode ray oscilloscope. It shows two different waves in figure 4 and in figure 5. In figure 4 we can see that there are 2.5 waves produced on the screen there. In figure 5 we can see there are 1, 2, 3, 4 waves. So figure 5 shows a higher frequency. Figure 4 also shows a low amplitude, and figure 5 shows a much higher amplitude wave. So the two conclusions that we can make are that in the second wave is louder, and that is because the amplitude is larger. Also, the second wave, because it had a higher frequency, is higher pitched. That's because we can see more waves.